All right, let's do this. So I am still waiting on some people to turn some stuff in. So still waiting on 10 Unit 2 tests. That's a big one. That's going to be a grade puller downer because that's a big one. 19 homeworks from last week, 11 formatives from the week before, 17 homeworks from the week before. So all I can do is ask, but just know that by the time that the next time that we meet, so Wednesday of this week, basically, by Thursday, all of that stuff is late, and so then it's a maximum of 60% when you finally do turn that in. If you turn it in before Wednesday, you're in that grace period, but after Wednesday, 60%. Okay, so don't miss out on those points. Okay. So today we are going to be talking about evaluating and graphing polynomial functions. Okay. So first thing is we should get into a definition of what a polynomial function is or what it looks like. Okay. So a straight up polynomial, okay, so a regular old polynomial is an expression. Okay? It's an expression, no equal sign, okay? Which means you can't solve it because there is no equal sign. Expressions cannot be solved. Expressions can just be simplified. Okay? They can be evaluated. If I knew what x was, I could evaluate it. Okay? So we can add, subtract, multiply, divide, evaluate, simplify, and our favorite word, factor. Okay? That's all we can do with a polynomial, okay? Because it's an expression. Now, a polynomial function, okay, that is an equation either written in function notation, f of x equals something, or it could be written as y equals something, or it could be just straight up written as like 6x cubed plus x squared equals negative 2x plus 5. Okay? Those are all examples of polynomial functions and the different ways that we can write them. Okay? So because it's an equality, we can solve it for x. We can graph it for its picture. We can find different things on it. And we can evaluate it also. the standard form of a polynomial or a polynomial function has all of its terms in descending order of exponents. So the biggest exponented term comes first, then the next one, then the next one, then the next one, and so on and so forth, until the very last term is the constant term. So the term with no variable on it. Okay? Now, one other part to this is that we have something here in standard form called the lead coefficient. And that is the coefficient, the number, if you will, in front of the biggest exponent. Okay, so the number in front of the biggest exponented term. And this biggest exponent, that is called the degree. Now, the degree is important. Okay? So if we're looking up at the polynomial function that I have written right up here under polynomial function, or just the right of it, that biggest exponented term would be x cubed. So the lead coefficient of this polynomial would be 6, and the degree would be 3. Degree is important. It tells us a couple of things, one of which we're going to talk about today in a little bit. Okay? But what really the degree tells us how many answers we should get if we're solving. If we're in this solving case, how many answers we should get. So if I was solving f of x for x, I should get 3 answers because the degree is 3. Okay? That's one of the nice things that the degree, the biggest exponent, tells us. Okay? So let's try our first example here. Let's reorganize this polynomial into standard form. Okay? I'll give you a couple of seconds here to 1, write it down, and 2, to reorganize it into standard form. So this would be f of x. My biggest exponented term is this one, negative 5x to the 4th power. Next biggest one would be plus 2x cubed. Next biggest one would be minus x squared. Next one would just be the 4, the constant term. So that is it written in standard form. And just a side note on these, the degree here of this function would be 4, and the lead coefficient would be negative 5. Okay? Lots of times you'll see me shorten up lead coefficient into just LC. Okay? So the degree is 4 because that's the biggest exponent, and the lead coefficient is negative 5. Okay? Now, let's talk some functions, some different kinds of functions based off of their degree and their type. Okay? All right? So the first function that we have is called a constant function. Okay? So it would be, in function notation, it would be f of x equals some number. Okay? Would be the form of it, if you will. Okay? The degree of that constant function is 0, because there is no exponent, there is no variable, so the degree is 0. The look, the shape, the touch, the feel of cotton is it's a horizontal line. Okay? So that's our first function. Our next polynomial function type would be a linear function. F of x equals mx plus b, or something, some different form of that. The degree is 1 because the biggest exponent here is 1. And it looks like a line. If my lead coefficient is positive, I would be going up and to the right. If my lead coefficient is negative, I would be going down and to the right. Okay? So that lead coefficient helps us in the direction of our graph. Next one is a quadratic. So we have an x squared term. It has a degree of 2. This is going to be parabolic in shape. With a positive lead coefficient, we would open up. With a negative lead coefficient, we would open down. Next two, I'm going to just move them up here a little bit. Cubics and quartics. Okay. Again, the degree is based off of the biggest exponent, so the degree there would be 3. That would be a cubic function. Positive lead coefficient. We'd have a little bit of a hump in there, depending on how it looks. Actually, that's a little too flat. Exaggerated hump in there. There you go. That's one. Left is always going to be positive lead coefficient. Right is always going to be negative lead coefficient. Quartic, biggest exponent is 4. And that's what those could look like. And so on and so forth. If we went with a 5th degree, a quintic function, we'll just say x to the fifth here. My degree would be 5. It would be quintic. Positive. Negative. And so on and so forth. Okay. Degree of 6, they would both end up going in the same direction, either with a positive lead coefficient, they would both end up going up. With a negative lead coefficient, they would both end up going down. 7, it would be discoing again. One would be going up, one would be going down, either positive or negative lead coefficients. 8, they would be both going the same way. 9, they would be alternating again, and so on and so forth. Okay? So, let's talk end behavior now. Okay? End behavior is what the function is doing on the sides of our graph. So what's happening on the right side of our graph, what's happening on the left side of our graph. Okay? That's what end behavior is telling us. Okay? So here are two different functions. Okay? And you can just sketch them in your notes to go along with it, but I would definitely have the sketch with them because that's going to help explain the end behavior. Okay? So one thing, let me tap the brakes here for a second. Let me move this stuff down here. Move that one. Oops, okay, that helps. And then let's move this down. This down. Oh, I should have left them together. As I like to say, these are riveting internets for those people watching along. Okay, there we go. Okay. So, the phrase, if you will, as x approaches positive infinity. Okay? That phrase means the right side of your graph. That's how it's said in math. What your function is doing on the right side is said as x goes to positive infinity. And as x goes to negative infinity, that stands for the left side of your graph. Okay? So, down here, the end behavior of these two functions. Oops, I gotta extend my page because there we go. So, as x goes to positive infinity, so this is saying right here, as x goes to positive infinity, that's saying as my function, as I get farther right and right and right on my graph, where's my function going? Well, it's going up. Okay? It's following this path and it's going up. So that function would be going to positive infinity. as x goes to negative infinity, this one down here is saying what's happening on the left side of my graph, or as I get farther and farther to the left, well, my function is going down this path, so it's going to negative, excuse me, infinity. Number 2 here, okay? Right side of my graph, as x is going to positive infinity, that's the right side of my graph, I am going to negative infinity because my graph is going down. The left side of my graph, it is going up right there, so it is going to positive infinity. Okay? Good times. Try those two. Find me the end behavior of those two functions. Right side of the left one of number 3, it is going to positive infinity. Left side for number 3 is also going to positive infinity. So as x goes to positive infinity, f of x is going to positive infinity. As x goes to negative infinity, f of x is also going to positive infinity. Both sides over here are going to negative infinity because they're both going down. Okay? So in summary for that, okay, so you have to ask yourself 2 questions. Okay? And actually I can get rid of these 2 because we already talked about what those mean. Oops. Okay? The first question that you should ask yourself is, what is the highest power, odd or even? Because if it's odd, they're going to go in opposite directions. All odd functions, all odd degree functions go in opposite directions. All even functions go in the same direction. Okay? And that is determined based off of the lead coefficient. So this one would have a positive lead coefficient, and this one would have a negative lead coefficient. This one would have a negative lead coefficient, and this one would have a positive lead coefficient. And that's really all that I care about with functions. Because all this funky stuff that goes on in the middle, that's going to be close to 0, and we're going to be able to figure that stuff out relatively easy. Okay? But so for all of those, that's how it's going to look. Okay? So what I would like you to do now in this particular one is, 1, I would like you to give me a sketch of this function. It doesn't have to be pretty. It doesn't have to be exact. I don't care. Okay? I just want you to give me a sketch of this function. Okay? And then 2, I want you to write me out the end behavior of this function. Okay? Go for it. So my sketch, it's my degree is 7, so that is odd. My lead coefficient is -2, so that tells me that my graph is going to start up here and look something like that. Okay. I know that it goes through this point right here, 0, -12. Because if I put 0 in for my function, 0, 0, 0, 0 minus 12 is -12. So I know it goes through down there. But if you didn't pick up on that, that's okay. I'm okay with it. I just asked for a sketch. Okay. My end behavior would be as x goes to positive infinity. This one is f of x is the name of this one. It is going right side, going down, so it is going to -infinity. As x is going to -infinity, left side going up, f of x then is going to positive infinity. Okay? All right? And that's the two answers that I would expect there. Okay? There. Now we're back. Okay? That's all I have for you today. So in this next mod here that technically you should be in class, if you are one of the 29, 40, 57, 64, 78 people that have, and I know it's not 78 people because there's only 55 total kids in the class, but if you are one of the 78 people that have something missing, I expect to see something in the next 20 minutes. Okay? If you are one of those people that have everything done, you rock. Okay? All right? Keep it up. Okay? You get the next 20 minutes off. Go get yourself a drink or a snack or something like that before your next class. So, okay? That's all I have for you. There is a week 7 worksheet posted on the It's Learning, and you can do the first 6 questions based off of today's notes. Okay? That's all I got for you. Have yourselves a great, grand, and wonderful day.